Welcome to Cosmos in a Pod Space and Astronomy series.
Glad to be here.
Have you ever wondered, what happens to stars after they die?
Of course.
It's not an end,
Right.
but it's like this really amazing transformation
Yeah.
that, kickstarts the creation of new stars and planets.
It's really incredible.
So today we're diving deep into nebulae,
Awesome.
which are the stunning, remnants of stellar evolution.
I love nebulae.
Okay, so, for starters, what exactly is a nebula?
So basically, we know that they're clouds of gas and dust, but where do they come from?
Yeah, how do they form?
They're basically byproducts of stellar evolution.
Okay.
Throughout their lives, stars fuse lighter elements into heavier ones in their cores, and that releases just massive amounts of energy. But eventually, that fuel runs out, and what happens next really depends on the star's initial mass, and that determines its fate and the type of nebula that it will form.
Okay, so a star's death
Yeah.
creates these nebulae.
Yeah.
Could you walk me through how that happens?
Okay, so let's imagine a star that's similar in size to our sun.
Yeah.
These stars, they don't go out with a bang. They kind of just...
They fizzle.
Yeah, as they run out of fuel, they expand into red giants.
Okay.
And they shed their outer layers into space.
They just kind of let go.
Yeah. And then those expelled layers are illuminated by the remaining stellar core, which at this point is a white dwarf.
Right.
And that's what forms a planetary nebula.
A planetary nebula. So that's kind of a misleading name,
Yeah,
right?
you're right.
Because it doesn't really have anything to do with planets.
It really doesn't.
It's just
It's a historical thing.
Yeah.
You know, early astronomers looked at them through telescopes and thought they looked like big planets,
okay.
but really they're the remnants of a dying star.
Okay.
And they can be all sorts of shapes and sizes.
Yeah.
Some are round, and others have these really complex, almost symmetrical structures.
Like the Ring Nebula.
Ex-
Yeah. I've seen pictures. It looks like a giant eye.
Yeah, it really does. In that bright ring that you see,
Yeah.
that's the illuminated shell of gas that was once part of the star's outer layers.
So cool.
And what's really cool is that they play a crucial role in enriching the interstellar medium
Okay.
with heavier elements.
So the carbon and oxygen, nitrogen.
Exactly. The things that make up planets and even us.
Yeah. The stuff we're made of.
So these elements are forged in the cores of stars
Okay.
throughout their lifespans. And when a star dies and forms a planetary nebula, those elements are then dispersed back into space,
Okay.
and they become the building blocks for future generations of stars and planetary systems.
Like a cosmic recycling program.
It really is a beautiful cycle.
Yeah, that's awesome. But what about the bigger stars?
Yeah.
The ones that do go out with a bang?
And yes, the supernovae.
Yeah.
These are just spectacular events, and they
Wow.
leave behind remnants that are completely different from planetary nebulae.
Oh, wow.
So when a star that is much more massive than our sun runs out of fuel,
Right.
its core collapses under its own gravity.
Oh, wow.
And this collapse triggers a shock wave
Uh-huh.
that blasts the star's outer layers into space with just insane force.
And that's the supernova explosion.
Yes.
The bright flash of light that can outshine an entire galaxy.
It's incredible. And the material ejected during the supernova doesn't just disappear.
Right.
It forms what we call a supernova remnant.
Right.
Its dynamic and chaotic structure of glowing gas and dust.
Right.
And these remnants expand outward for thousands of years.
Yeah.
And they interact with the surrounding interstellar medium,
Uh-huh.
creating these complex and mesmerizing shapes.
So like the Crab Nebula.
Yes, another great example.
Yeah, it's amazing. It looks like a giant spider web.
It really does. And the Crab Nebula is one of the most studied objects in the sky.
Oh, wow.
Yeah, and it's still evolving, even today.
Really?
Centuries after the initial explosion.
Wow, that's wild. So supernova remnants are basically the leftovers of a star's death throes.
Exactly.
But they also contribute to this cosmic recycling, right?
They do.
They enrich the interstellar medium with heavier elements, too.
Absolutely. In fact, supernovae are the main source of the heaviest elements in the universe.
Okay.
We're talking iron, gold, uranium.
Wow.
Those elements wouldn't exist if it weren't for the intense heat and pressure that's found at the heart of these dying stars.
So the gold in my ring
Yes.
came from a supernova.
It's amazing, right?
That is so cool. It makes you think about how everything is connected in the universe.
It really is mind-blowing. Every element in our bodies, on our planet,
Wow.
the air we breathe,
Wow.
it was all once part of a star.
So we're made of stardust.
We are. And the nebulae that we see are windows into this incredible cycle of cosmic creation and destruction.
That is wild.
Yeah.
So we've talked about two types of nebulae. Are there others?
There's another type called Wolf-Rayet Nebulae.
Wolf-Rayet.
Yeah.
Okay.
These are formed by extremely massive stars
Okay.
that lose their outer layers through these really intense stellar winds.
So like much stronger than the processes that create planetary nebulae.
Oh yeah, much more powerful.
Interesting.
So these stars are basically shedding their outer layers long before they actually explode.
Oh, wow.
Yeah, and these winds are so powerful that they create these stunning bubble-shaped nebulae
Wow.
that are enriched with heavy elements. It's like the star's way of giving back to the galaxy even before it dies.
So cool. So it's like preemptively seeding the galaxy with the building blocks for future stars and planets.
Exactly. And they provide us with a really unique glimpse into the late stages of massive star evolution.
This is a lot more complex than I imagined.
It's amazing, isn't it?
Yeah, so we have all these different types of nebulae, all formed from the deaths of stars.
Yeah.
And they all play a role in enriching the interstellar medium with these heavier elements.
Right.
It's like this beautiful, chaotic dance of creation and destruction.
Exactly. It's happening all across the universe.
That's crazy to think about.
I know, it's beautiful. The death of a star isn't just an ending. It's also a beginning, a chance for the universe to create something new and maybe even more wondrous. And these nebulae, with their beauty and intricate structures, remind us of this continuous cycle of cosmic renewal.
That's incredible.
And the story doesn't just end there.
Yeah.
These nebulae, enriched with all those heavy elements, they play a crucial role in triggering the birth of new stars.
Wait, hold on.
Yeah.
How can something that's born from death, like a supernova remnant, actually lead to creating something new?
It's a fascinating process.
Yeah.
Imagine like a supernova remnant expanding outwards, and its shockwave is just sweeping through the interstellar medium.
Right.
That shockwave can compress nearby clouds of gas and dust and trigger their gravitational collapse. Oh, wow.
Which leads to the formation of new stars.
So it's like a domino effect?
Yeah, that's right.
One star dies, creates a shockwave that can ignite the birth of countless others.
It's pretty amazing.
Yeah, it is. The scale of these processes is mind-boggling.
I know, it's incredible. And it's not just the shock waves.
Okay.
The heavy elements that are dispersed by nebulae, those are essential ingredients for star formation.
Okay.
Because remember, stars are mainly hydrogen and helium, but heavier elements play a crucial role in forming protoplanetary disks.
Right.
Which is where planets are born.
So no planets without those heavier elements scattered by nebulae.
Exactly.
Wow. So this cosmic cycle of death and rebirth.
Yeah.
It's all connected.
It really is. It's this intricate web.
Yeah.
Each generation of stars is enriching the galaxy with heavier elements.
Okay.
Which paves the way for the formation of new stars, planets, and maybe even life itself.
That's really cool. Can we talk about some specific nebulae
Sure.
that have captured people's imaginations?
Yeah. Let's start with one of the most iconic planetary nebulae.
Okay.
The Helix Nebula.
The Helix Nebula.
Yeah, it's in the constellation Aquarius.
Okay.
And it's often called the Eye of God.
Oh, yeah, I've seen pictures.
Yeah.
It's so cool. That glowing ring of gas and dust.
Oh, I know, it's amazing. With that faint white dwarf in the center.
Yeah, is it visible to the naked eye?
Not really. Not from areas with lots of light pollution.
Okay.
But if you have good binoculars or even a small telescope, you can see its glow.
So cool. Okay, I'm adding that to my list.
Definitely.
What about supernova remnants?
Oh, there are some great ones.
Yeah.
One of the most famous and recognizable is the Veil Nebula.
Okay.
It's in the constellation Cygnus.
Okay.
And it's just vast.
Yeah.
An intricate structure of glowing filaments of gas and dust. It spans several degrees across the sky.
Yeah, I've seen images of that too. It looks like a curtain across the stars. It really does. It's beautiful.
Yeah.
And it's the result of a supernova that happened thousands of years ago.
Wow.
And the shock wave from that explosion is still interacting with the interstellar medium.
Wow.
It's what creates those delicate, wispy filaments we see today.
So cool. It's amazing how long these events impact the universe.
I know, it's incredible.
What about the Crab Nebula?
The Crab Nebula,
Yeah.
that's unique for a few reasons.
Yeah.
First, it's relatively young,
Okay.
astronomically speaking.
Okay.
The supernova that created it was actually observed by Chinese astronomers
Oh, wow.
back in the year 1054.
Wow.
So we have detailed records.
So cool. So we're seeing the remnants of an event that humans 1,000 years ago saw happen.
I know, right?
That's amazing.
And because it's so young, it's still very dynamic and energetic. It emits radiation across the entire electromagnetic spectrum.
Whoa, that's crazy.
So it's a treasure trove of information.
So it's not just beautiful to look at. It's also helping us learn about supernovae.
Exactly. We've learned so much about supernovae and neutron stars and the dynamics of the interstellar medium just from studying the Crab Nebula.
Wow. So the death of a star is illuminating our understanding of the universe.
It really is.
What other secrets are hidden in these nebulae?
Oh, there are so many mysteries still to unravel.
Yeah.
Like, we're still trying to understand how these intricate structures are shaped.
Right.
What role do magnetic fields play?
Right.
How do the remnants interact with the interstellar medium over time? These are all questions that astronomers are still trying to answer.
It's exciting to think that each new observation brings us closer to understanding these cosmic wonders.
I agree. And as our telescopes get more powerful and our techniques more sophisticated, I think we can expect even more breathtaking discoveries and deeper insights into this whole cycle of stellar death and rebirth.
It shapes our universe.
It's an amazing field to be in.
Yeah, that's really cool. So these nebulae born from the death of stars, they're not just pretty to look at.
Right.
They hold the key to understanding, like, our place in the universe.
Yeah, it's true. Everything we see, the planets, the stars, even life itself, it's all connected to this cycle of stellar death and rebirth.
Right.
The elements in our bodies, the air we breathe, the earth.
Yeah.
It all came from stars that lived and died billions of years ago.
So we really are made of stardust.
We are.
It's pretty humbling.
It really is, you know. It makes you realize that we're not just observers in the universe.
Right.
We're participants.
Yeah, that's cool.
I think so.
So for our listeners who are maybe feeling a little overwhelmed with all this talk of exploding stars and cosmic recycling, what's the main takeaway?
I'd say, first of all, nebulae are just beautiful. I mean, they're some of the most visually stunning things in the universe.
Right.
And they inspire awe and wonder.
Yeah, for sure.
I mean, just look at pictures of the Orion Nebula.
Yeah.
Or the Eagle Nebula. They're like masterpieces.
They are.
A testament to the beauty of the cosmos.
I agree. They're like works of art.
They are.
But it's more than just how they look, right?
Exactly.
There's like a deeper meaning.
Yeah, nebulae are more than just pictures. They represent like the interconnectedness of everything in the universe.
Yeah.
They remind us that endings can be beginnings, that destruction can lead to creation.
It's a powerful reminder for sure.
Yeah.
That even with death, there's renewal.
Right.
A chance for new things to come about.
Exactly. And by studying these nebulae, trying to understand how they're made, it allows us to understand our own origins, to put together the story of how we came to be.
That's really cool.
Yeah, it's a journey of discovery that connects us to the very fabric of the universe.
It's not just science.
Right.
It's a story about our existence and our place in the cosmos.
Yeah. So next time you're looking up at the night sky and you see a faint smudge of light, remember that you might be looking at a nebula. A stellar nursery, a cosmic graveyard, and a testament to the never-ending cycle of creation and destruction that drives the universe.
That's amazing. And for our listeners who want to learn more about nebulae, make sure to follow and subscribe.
Please do.
To our podcast and YouTube channel.
We'd love to have you.
For more deep dives into the mysteries of the universe.
Absolutely.
Until next time.